Hey guys, welcome to another video. So today we continue on with the nice question series of questions that I've been doing. Today's question comes from the Year 12 Advanced Syllabus. A question from the James Roos 2023 trial paper. Last question, in fact, so potentially the hardest in the test paper. The topic today, it relates to probability, normal distribution. So a lot of students, when it comes to this topic, if it's textbook easy questions, they're okay, but when they sort of put a little bit of twist, they struggle. So we'll see how it goes. So if you haven't already done so, please subscribe to the channel, tell your friends, and like the video, please. All right, let's go on. Now, James Roos. All right, so this question, let's highlight the key things, right? An airline company operates regular flights between cities A and B. The flight time X. Now, X is defined as the normal distributed variable, right? Normally distributed with a mean of 80. Okay, cool. So it's got a mean of 80. What's its standard deviation or what's its variance? Sigma of, okay, they don't tell you it. It's missing. Sigma squared is its variance, right? Now, the next point is really important. Also, 2.5s of flights take longer than 90 minutes, right? So right now, the flight time is defined to be the random variable, and 2.5% of all flights take longer than 96 minutes, right? Okay. What's the questions here? Label the normal distribution curve, okay. Find sigma. What percentage of flights take longer than 90? Once you found sigma, you should be able to find that. In order to attract customers, management, 99.5%. Okay, cool. Now, I'll get there shortly. But before I begin, right, to do a question like this, you must remember, see this 2.5% here? That is not a random number, right? That number, for those that know their stuff, right? Know that when it comes to a normal distribution, right? We know that if this was mu, right, the average, then I know that within one standard deviation, right, I have 68% of all results, right? Within within two standard deviations, right, I should have 95% of all scores, right? And then within three standard deviations, yeah, I should have, so mu minus 3 sigma, mu plus 3 sigma, I should have 99.7% of all percent of all scores, right? They call this the empirical rule for normal distributions. Now, those numbers, if you were really on top of your game, and I say this to my students all the time, because the normal distribution is symmetrical, right? You can actually allocate all the percentages to the areas in the curve. So for example, 68 divided by 2, that's 34%, and 34%, right? Symmetrical. 95, now 95 divided by 2, 47.5, so that's already 34. So this leaves 13.5% and 13.5%, right? And then likewise, the last percentage, 99.7%, divided by 2 is 49.85. So this leaves a 2.35%. Can you make sure you do the maths for me, right? Because these three numbers should tie up to half of 99.7. And the remainder 0.3% leaves me with 0.15% on the outliers to the left and right. Yeah? That makes up a full 100%. Now, why am I telling you this? Because in this question, right, we need to right now determine the value of sigma, right? We don't know what it is. In fact, I'll label the diagram later. But for now, let's do part B. I need to find what sigma is. This information here, right, is super crucial, right? 2.5%. Where is that on the graph? If it takes 2.5% of flights take longer than my time, right? So I'm looking for percentages that add up to 2.5%. That's this guy here, right? Yeah. These two add up to 2.5%. So basically, right, if my flight time, if my X in this case equal to 2 standard deviations above the mean, then 2.5% of that time would be greater than 96 minutes, right? So I guess in this question, it's basically trying to tell you this, right? That the probability when X is greater than 96 minutes, that equals to 0.025, so 2.5%, right? So back solving that, right, for part B, right? That's basically saying if I standardize this, right? So, in fact, the way I'm going to do it is, so that's what it means. But when you try to solve it, right, I know that mu plus 2 sigma equals to 96%, right? That's really what it's trying to say to you, right? Yeah, equals to 96%. And then you find the value of, oh, sorry, not 96%, 96 minutes, right? And then we know that mu is 80. Right? What's that? 2 sigma equals to 16, sigma equals to 8. So in this question, I mean, you could have got that when you plug it into this, but all it's trying to say is at this point, right, where there's 2.5% above it, mu plus 2 sigma is 96 minutes. Got mu, 80 minutes, solve it, therefore got sigma. Now, I thought I'd find sigma first because when I label it on the diagram, right? So the question goes, label everything you know. This is all you need to do, right? On the diagram, you basically go, well, yeah, I've got 80 minutes being the mu, right? That's mu over here. And then this is obviously 80 plus 1 sigma, 80 plus 2 sigma, right? And I know that 80 plus 2 sigma is 96 minutes, right? In this case, right? Not that you need to label that, but that's basically what it meant. Because over here, right, for this area here, right, this is 2.5%, right? Yeah, so in the solutions, they just needed you to label that now. They didn't really need you to label this as 96 minutes, but that's how I did part B. That's how you do it. So all they're after really is a labeling of the mu and the sigma, 80 plus 2 sigma, right? Now, guys, is that okay how I found part B? Because part B, all they want you to do is use that pink information where it's 2.5% of the flights are longer than 96 to then go, well, at 96, I've got 2.5% above it on the normal graph, and then I find sigma equals to 8. Once I find sigma equals to 8, so I'm just going to scroll down, move this guy up. In fact, maybe I'll move this guy over here so I have a bit of space. Does it fit? Yeah, probably. That'll do. All right, just chuck it down there. All right. Come up here so I can zoom in, right? So I've got a bit of space to work with. All right, let's go. Part C. What percentage of flights take longer than 90 minutes, right? So this is basically going probability that X is greater than 90. Yeah, now, so I'm going to try to use standardized format to do this, but I know that that guy there equals to, if I wanted to standardize, right, and use my table, which I copied in the next one. So this is like 1 minus probability. Now, I'm doing this just in case it's not a nice sort of 1, 2, or 3 standard deviations above, right? That, guys, you know that to convert this into a standardized table, right? 1 minus. So standardized Z, right? What do I need to do? The conversion, do you guys remember? Right? To convert X to Z, right? This guy to this guy, right? Yeah, maybe highlight that in green. This guy to this guy. What do I need to do? Z equals to X minus mu on sigma. Now that I have mu and sigma, right? So to make that guy into that guy, I take the value minus mu divided by sigma, right? 1 minus Z less than, what's that, 10 on 8? That 1 point, what's 10 on 8? 1.25? 1.25. Now, that's not a nice number. So I need to find that on the table, right? 1.25. So remember that number, 1.25, right? Because let's go quickly to the standard normal table. 1.2 there. Right, 1.2 is over here. 5 is here. So let's follow that. This one here. So, yep. 0.8994. So 1 minus 0.8994 No, sorry, 8944, was it? Yep. And then what's that, guys? 0.1056. So 10.56%. Cool. Easy. Is that okay? So now, how did I know to use a table? Because this number here, if it was 1, 2, or 3, I think I can use the normal curve there, but it's 1.25. Feels like if it's anything but a whole number, I've got to use a standard table, right? Which should be given to you as part of your test, right? Now, is that okay so far? So basically part B was, now a lot of people couldn't get past how to use the pink fact. That's how you use it. And then once you find sigma in this case, you can use the standard normal conversion from X to Z, right? And then use the standard normal table of values to help you knock it out, right? All right, next one. Last question. In order to attract customers, the management of the airline company decides to refund the fares if the flight takes longer than 80 plus T minutes. The company wants to keep 99.5% of all fares. So calculate T. So you're trying to find X, right, which is equal to 80 plus T, where 99.5% of all numbers are less than that time, right? So this is what they want, right? They basically want you to go, part D, they want you to go find the probability, right, X, right, which is less than 80 plus T, right, to be 0.995, right? That's what they want. They want you to find the value of X there. Yeah, so firstly, I'm going to standardize this, right? Because I can't deal with X by itself. I need a table for this now. I need more space. So I'm just going to, sorry, drag. So I didn't just fit everything in a nice slide. Right, perfect. Does that make sense, guys? So they want me you find the value of X. So this is what I do. Now, whenever you deal with this, I always say to my students, can't deal with X, right? Your standard table needs to be Z. So I'm going to standardize this expression where I turn it into Z by going 80 plus T minus mu divided by sigma equals to, this side doesn't change. I haven't changed anything on this side. I'm just standardizing the inside, right? Now, once that's standardized, let's clean this up slightly. Sorry, I don't need equal signs there. Right, so Z, the 80s go away, so it's just less than, what's that, T on 8. Yeah, equals to 0.995. Now, in this case, we do the opposite of above, right? They didn't give me, you can see above, they gave me 1.25, and I'll go to the table to find it, right? Find the answer. In this one, they gave me the answer from the table, and they want me to go to the table, find the answer, right? And look up what values of Z gives me 0.95. Now, sometimes there's not a nice number that equals that. So let's have a look, right? Remember, 9.995, right? Now, so I'm looking for 995 somewhere here, right? The closest one, right? Let's have a look. 0.995. That one's close. Oh, that one's close. These two, right? Between these two. Yeah, can you see that? Right? So my value is between here. So the question is the probability of Z less than or equal to what, right, would give me 0.995, right? To find out what, it looks like it's the average between these two. So whatever the value is, let's say 2.5. So in this number here, it's going to be 2.5, what, 2.57 and 2.58, right? It's the average of those two. So the answer should be 2.575-ish, right? Does that make sense? Because I'm looking for the average, right? You can call it interpolating or whatever. If it's 0.995, I want to be in between those two, right? Just to be accurate. So 2.575 is the answer that I want over here. So what that means is this number here should be 575, right? And then I just solve that, right? So therefore, oops, wrong color. Therefore, T on 8 equals to 2.575. Therefore, times 8 up, you guys get 20.6 minutes, right? That's all they want, yeah? Times it up, 20.6. So guys, I like this question because a lot of people get stuck with, I guess, the start of finding sigma, right? But hopefully that's okay. The fact that they gave you a nice percentage of 2.5%, right, allows you to use the empirical rule to go, okay, sigma's a nice 8. Once you find that, they give you one question, right, where they go, find a time greater than 90, find the percentage of flights greater than 90. So using the standard normal table, right, we standardize and find that. I like part D because you go the opposite, right? They give you the percentage and they want you to go find the Z values that correlate to that percentage. So we go backwards, and in this case, we average the 2 times because there wasn't one that was exactly 99.5%. Once you average it, set T on 8 equals to that, then you're done. How's that, guys? Thought it was a nice question for me to go through from James Roos. If you like that, please like the video, subscribe to the channel, and tell your friends. I'll see you guys later.